This is a new question here. It says add curved arrows to the following SN2 reaction. You can't really see the SN2, so maybe I'll zoom in. So it says add curved arrows to this SN2. So we know it's SN2 reaction, so that's good. We have to figure out, we're adding our curved arrows. So what does our mechanism say? So I have here, this is a H bond OH group, and then I have here, this is some H bond C bond Br bond H bond H. And then I'm going to get, this is simply an SN1 reaction here, and I get a substitution, or I get OH bond C bond H bond H bond H plus Br minus, right? Very, very classic example of a SN2 reaction. Okay. So again, here I'm adding some curved arrows to this, right? To this SN2 reaction, right? So how would I add the curved arrows here? So again, I believe, oh, this is the answer here, right? So let me look at the answer here. So again, here, minus here is good. I have an electrophile, which is the OH group. It's going to attack the positively carbon, right? I have here, again, here, this here is my negatively charged ion here. So this is a good nucleophile. And again, this here is my bromine, is also partial, it's not negative, but it's partial negative. And this here is a partial positive, right? So what it's going to do is one step, it's going to, this minus is going to come to this carbon, attack the carbon, and then it's going to kick the bromine out, and then I'm going to get this this product here, this alcohol, right? So I have a hydroxyl group, I have an alkyl bromide in this case, and then I'm going to make an alcohol, right? And then Br minus is simply just the side reaction here, and Br minus is the side product here. So that's good. That's the question 1 here. I'm going to get this. So this curved arrow is indeed not correct, because I need to, for this one I would need to it actually attacks this this carbon here, right? It attacks the carbon and not the hydrogen here. So this question is kind of misleading, right? This negatively charged is attracted to this partially positive carbon here, not the hydrogen here. So that's kind of incorrect here in this case, in terms of the diagram here. But I'm going to forgive it, because that wasn't the question. And then this is another one. So I have here, this is H3C bond CH2 bond. I have a Br here, and then I have, this is another, this is OCH3, right? Okay, so this is this here is a negatively charged compound here. So I'm gonna do that in blue. This is negatively charged. Again, bromine here is negatively charged, and this, which means this carbon is partially positive, right? So again, what it's going to do, it's going to, this is again, is another SN2, right? This O oxygen is going to come attack this carbon here, and it's going to kick out this bromine. So I'm going to get a H3C that's not affected here, and then I'm going to get this is a CH2, and then this here would be an OCH3 would be my answer here, and then I get bromine as the side product. So again, this here is a one-step reaction, right? SN2 is a bimolecular reaction, and it takes one step, right? Backside attack, inversion of stereochemistry, right? So you get an SN2 reaction, and it's simply just a substitution between bromine, using this here would be a OCH3 group. So it's a very strong nucleophile. So again, one-step reaction because it's strong, good leaving group, and it's a strong nucleophile. Sweet. And then let's do this last one here. I have, let's see. I don't like the way they draw these ones, but it's okay. HCH3, I have one carbon in the middle. I have CH3, I have Br on this side, and then I have CH2. Oh, okay, I have CH3, right? Okay, that's fine. They drew the hydrogen here, right? And then plus I have another OH, right? OH here. And then what am I going to get? So again, here let's label my charges. I used red as negative, right? No, or use red as positive. So negatives would be, this here is I have a negatively charged nucleophile here, and my bromine here is negatively charged, which means my my carbon here is partial positive, right? Partial positive here. So what's going to happen is this negatively charged, or sorry, I was going to do this in red, my bad. This one here is in red. So what I'm going to do, again, this negatively charged, sorry, this is positive. What am I saying? Carbon is positive. Okay, so what's going to happen is this negatively charged nucleophile, strong nucleophile, is going to come and attack. It's going to come and attack the positively charged carbon here, and it's going to get some type of substitution reaction, right? However, what they have here is something that's different. They have this solution is super weird. It says I get a double bond on the carbon, but that's an elimination, and they get H here. So this is an E2 reaction, not an SN2. Oh, I didn't read the question. Sorry, this is an E2 reaction. So E2 is different, right? When we talk about elimination or E2 reaction, again, it's still one step, but it's an elimination, right? So in this case, elimination, what it is this hydrogen is basically what this happens is this oxygen here is going to attack this hydrogen, and then this is going to collapse here, and it's going to kick out the bromine. So how that happens is, and then I'm going to create a double bond. So it's going to create the thing I have on my left hand side, and I get water, right? This hydrogen here becomes bonded to this OH group here, so I get water here. So this is an E2 reaction. Sorry, I didn't look at the problem here. So the first two were SN2 reactions because I am substituting my Br group for the OH group or the OCH3 group, and this here is an E2 reaction, right? Again, my negatively charged is going to attack the hydrogen of the carbon next to it, and then it's going to create a double bond basically right over here. So I'll do that in red. It creates a double bond right over here to make the double bond CH2 here. And this bromine gets kicked out, and I get the water here, and I get H2O, and I get Br minus, right? Because again, the bromine doesn't have anything to bond with here, so these are my side products, Br minus. Okay, so that's correct here. So let's see. I get CH3CO. So this is correct. These two are correct. Negative charge attacks the carbon here, and then it's attacking this carbon, not this hydrogen, and then it goes out. That's fine. This is an E2 reaction. So E2 is going to so the bromine's going to leave first, which is fine, and then it's going to attack, right? So again, this here is that actually this is an E1. They're depicting an E1 here because E1 would be two-step, right? I need a formation of a carbocation, which is this first step here, and then it becomes elimination. But this here is actually this here is a SN1, so this is not a correct solution here. Do you see what's wrong here? I have a carbocation. It's creating carbocation in the first place, which means I have either a E1 or SN1, and the hydroxyl group is actually going to attack this positive charge. So it's going to actually add. So it's a substitution. This is an SN1 reaction, but here I have an E2 reaction. So this is a wrong solution, actually. So these two were correct, and this bottom one here is wrong. So I'm going to say the first two solutions were correct. The third solution is incorrect because it depicts this would be an SN1 reaction because I have formation of carbocation and then nucleophilic attack, while the question was asking for a elimination in E1 reaction. So again, elimination E1, if I were to draw out the mechanism and draw out the, or sorry, this was the E2, right? This is E2, not E1, E2, my bad, for an E2 reaction. So one step process here. So the third one here is wrong. So I'm going to say the solution is incorrect in this